All right. Good morning, everyone. My name is Paul Hurlocker. I work for Capital One. I'm a VP in the Center for Machine Learning. And so thanks for joining. And today I'm going to talk about intelligent identity and access management, a solution that we built for that. One of my colleagues, Brian Maher, is going to kind of go into the details. So I'm going to set things up. So who is Capital One? I think most people are aware of Capital One, as a bank, at least the attendees here that are from the United States. But it's interesting, our founder and CEO, our co-founder and CEO, Rich Fairbanks, recently said, we're actually a technology company, and we're using machine learning to solve hard problems. We just happen to be a bank. So we've been on a really interesting journey, and I'm going to talk about that a little bit before we dive into the details. So we're a 25-year-old company, which is pretty rare for being such a large financial institution, and our competitors most of them are over 100 years old. As I said, we're still founder-led. 15 U.S. cities, Canada and the UK is our geographical footprint. We're the largest U.S. direct bank, the third largest credit card issuer, second largest financial institution, auto loan originator. And we're 98 in the Fortune 500, and we've got lots of customers and associates. So from Capital One has been working in machine learning and data science since its founding. So we have a lot of experience with that. Of course, we're taking advantage of the evolution, that's going on in, with machine learning and big data and things like that. But two of the areas that we really try to focus from a machine learning perspective on is improving the customer experience and catching the bad guys. So these are examples of areas like we built Eno, which is a chatbot, and Speakeasy, which is our IVR system. We use, from a digital marketing perspective, we're using machine learning to determine the best way to interact and serve our customers. And of course, anti-money laundering and fraud, we're working hard to protect our customers and reduce our risk on that front. So the problem statement, let me frame this a little bit. So over probably the past 6 years, there's been a massive transformation that we've been undergoing. So we're moving to the cloud. We're a really large customer of AWS, and the mission is that we're going to be all in on the cloud and out of our data centers, and that's going to happen at the end of this year. So it's a massive transformation. We're also embracing Agile and have embraced Agile for a number of years across our company. We're also adopting microservice-based architecture across the company. Probably the most exciting thing is we're doing a massive data transformation, with an enterprise data lake and streaming data platform, which will allow us to do machine learning at scale across the company. So the ultimate so what of all of these investments is machine learning. But it's interesting, doing all this. It's hard, but it's also adds different types of complexity, and that's something that we want to talk about today in relation to identity and access management. So as I said, all of this technology transformation. Imagine the granularity of the services and systems we have in our environment, the data being in these environments, and we're in a highly regulated industry, and we need to be sure to only provide the access that people need. But we need to do that quickly. It's really important to us to have a experience for our technical associates where they can get onboarded quickly, they can get access to the systems that they need, and it's difficult to, it's a difficult problem that you can't solve just from a human perspective. You need to add intelligence to it. So in the end, we want our people, our new associates, to be as productive as possible when they join Capital One. We also want people to, when they're switching from teams, to have access taken away appropriately when they don't need it, and to get the access quickly that they need to move forward with their work. So we're serving multiple personas here. Hiring managers, it's just good risk management, but in general, we need to allow hiring managers to approve access for our employees in a way that they can frankly understand it. A lot of times, depending on the level of the hiring manager, they're not always, kind of in the details of what kind of levels of access they need. Also, the employees, when they come in, a lot of times, in the past, they would just kind of have to go to a leader on a team to figure out what access levels they need, and it was kind of a iteration through that process to ultimately get the right level of access. And again, this is all in the backdrop of an increasingly complex yet flexible environment. So we stepped back and looked at this complexity and decided that machine learning was really the only way we could make this tractable. So we're, so Brian Maher, who's about to join us on stage, is going to kind of take us through the details of how we solve this problem. He's going to frame it up a little bit more and kind of go into some of the technical approaches, algorithms, and then ultimately a demo of the experience that we've built to solve this problem. So Brian Maher, please join me.
Thanks.
Thank you, sir. Good luck.
All right. Mic on? Good deal. All right, so generally when we try and assess whether or not to apply machine learning, we ask two questions. Question number one is the data so large that a human is unable to have the capacity to identify the patterns they need to solve the problem? So that's number one. And number two is that human capacity scalable? And in this case, both were perfect check the boxes, and I'll explain why. So I've only got 30 employees on my team. Seems relatively manageable, right? I should at least be able to know their names, a little bit about them. But across those 30 people, they have roughly 5,000 entitlements. And what an entitlement is a different level of granularity of access. So you get access to a system. You might have read access, you might have write access, might have delete, might have admin. So across my 30 people, there are 5,000 different types of access across each one of them that, to really do my job, I need to understand that pretty well. Now, truth be told, do I actually understand all of those? No, not so much, but thank God now I don't really have to. If you're to think about scaling this out across Capital One, we've, all the employees that we have, so about roughly 70,000 when you include contractors, now we're talking about 13 million different variations of entitlements. So if I did know my 5,000, you're talking about 2,600 people like me to be able to do this at scale. And again, that is not a scalable human capacity. So if you add to this the fun fact that US adults generally get somewhere up to 50,000 vocabulary words, if I've got to spend 10% of my mental capacity for my vocabulary to understand entitlements, if you couple that with all the banking jargon I also need to understand to work at Capital One, I'm getting into the danger zone where my soon-to-be 9-year-old's vocabulary is starting to surpass my speaking vocabulary. So this is not a scalable solution. It's very complex, and this is where we identified we needed an intelligent, scalable, and automated solution, and that's where machine learning comes in. So what I'm going to show you now, it's a 2-minute demo. The guy doing the demo, the voice on the demo, is actually our Austin Osborne. He's our head machine learning engineer on the project. And he's going to walk you through the conventional way that we've generally looked at assessing access. And then you get a sneak peek into the machine learning application that we also built that has something a little bit more intelligent and user-friendly for people managers like myself. So definitely a little bit of a selfish play on that. On the second part, you will see some visual analytics, and I'll explain there is some stuff that's actually going on in the background, and I'll tie that back in a later slide. So let's get started.
Hi, my name is Austin, and I'd like to introduce an access management tool called Traxxas. Traxxas is a one-stop shop for all your access management needs. You can interact with the tool through three main functions: compare, recommendations, and catalog. The compare function allows me to look at any combination of associates at Capital One and view their entitlement and role profiles. So you can see here, I've selected Dane and Chris, and then in the table, their profile information is populated. Each column represents an associate, and the check represents whether or not they have the entitlement or role in question. You can see on the right there's a plus icon, and it's currently grayed out. This means that I already have this entitlement as well. So as I look on the next page, some of the icons now turn green. So let's add some now. Now you can see that my cart is populated, and we'll get to the cart a little bit later in the demo. The second function is called recommendations. This feature utilizes an unsupervised algorithm called the Louvain method to generate recommendations based on associates that are similar to you. So you can see down in the bottom of the screen, it's been detected that I'm similar to these associates. And because of that information, I've been given a curated list of entitlements and roles that I maybe should add to my profile. This list is sorted by prevalence, so I can really see which things are more likely for me to need to add. So I can add from here as well. And you see that reflected in the cart. As a note, the loading image that appears when I click the add button is going through a sequence of validations. It's verifying that I have the correct CBTs, there's no segregation of duty violations, and a few other things. Our final feature is called catalog. This is sort of...
All right, let's stop there. So what I love about that application is you saw the graph in the background. I'll talk a little bit about graphs here in a second. But the user has no idea that machine learning is coming into play, right? So what it's doing is it's taking that persona of Austin coming in, and if you look at the previous process, Austin has to select two people and say, I think I'm going to work in a role that's similar to these two people. Now, let's compare and see what access they have, and then I can make a choice and determine whether or not I want that access and add it to my cart. We kind of stole a little bit of that from maybe the Amazon UI, but he had to make a decision in discretion by himself, right? Now, if he's new to the company, he's not going to be able to do that. He's probably not going to know the network well enough. So when you look at the other side, we invoke this algorithm, and it does all the intelligence for him and makes a recommendation in a kind of a weighted format, so he can start to look down and have a certain degree of confidence that, well, these are the different access I need. So let me explain how we did that. So it's a mix of some native AWS capabilities, some good old-fashioned statistics, and then an unsupervised machine learning algorithm. So I'll go a little bit into detail of each one. So step one, and we actually started with multiple different permutations around databases, and we got to graphs, which was definitely the right solution. It wasn't where we started, but we got there finally. So we built a graph of all the employees and all their access profiles. Now, if you look at the 70,000 people and you do some stats, it's roughly about 2.5 million different relationships that we build out daily. So it's a material graph, definitely data at a scale that a human's not going to be able to comprehend. And if you're not familiar with graphs, there's two things that you really need to understand. You got these things called nodes, and you got these things called edges. So in this case, the nodes are people embedded with their access profiles, and then the edges are the connections between the people. All right, so step one, we're just building that out, okay? Graphing out 70,000 people and how they connect with everybody else and their relative access profiles. Then the next step is the legacy quantitative statistics approach, where we use something called the Jaccard Similarity Index. So in simple terms, what it's doing, it's comparing the union of two data sets. So up here we got associate A, associate B. We're looking across their access profiles and looking to see what percentage of their access profiles are similar. And what that does is it starts to score the edges. Right? So I talk about the graph, you got these nodes and these edges. So across the 2.5 million relationships, we're building out similarity indexes for each person relative to everybody else in the company. So there's some additional engineering that we have to do to make that a little bit more performance friendly. I won't go into that. That's actually real lower level compute. But there's something called min-hash that makes that a little bit more speedy that we apply after we build the graph and after we do the similarity indexes. So when we start scoring these edges, what we start to identify is associate A and associate B, they have roughly 50% of the same access profile. And then associate B to associate C, maybe they have 60%. And then you find someone with 80%, someone with 20%. And we start seeing that agnostic of their role, their job level, where they are in the organization, how can we actually determine groups of people that have similar access profiles? Now, the legacy way of doing this is you build roles for people and you generally work your way up kind of the hierarchy of I look at a person, I look at their role, their job function, where they are in the organization, their job level, and then you build out kind of a static profile. The problem with that, as Paul alluded to, is since we've moved to the cloud, like that doesn't work anymore. Like our environments are so dynamic, they change way too frequently. As soon as you make one of those profiles, a week later it's outdated. So like that legacy process doesn't scale when you're working in an environment that's growing exponentially because you're building more and more stuff. You're decoupling architecture. Now you used to have these monolith applications. Now they're like 5+ different microservices. You know, that approach doesn't work when you're in a dynamic environment that's changing continuously. So the third step, and this is where it gets kind of cool. I'm not sure the laser's not working. All right. Let me explain here. The third step is how do we identify those groups of people that do have like access profiles? So we use this thing called the Louvain community detection. And what it does is it starts to cluster people together that have like access profiles. Again, agnostic of all the other data. It's a person and their access profile. And what you start seeing is, and we use, I think, 70% as a threshold. So groups of people who have 70% overlap in their access, they start to build a community or a cluster. And that starts to feed into a recommendation engine that I'll get into here in a second. We initially, we were a little overzealous when we first built this. Again, I think it's evolved multiple different times in the architecture. But we were like, we need this thing to be active, always on. And we're like, so we had it built in multiple AZ zones, EC2s, highly resilient, probably a little bit too much horsepower, until our cloud police came and told us and says, by the way, your CPU utilization is like this. And what we realized is, well, people are not actually managing access all the time. But this is a good use case for AWS Lambda. So we switched to a Lambda architecture, and you can go into this application, as you saw Austin do previously, and determine what persona you're coming in, and you say that I want to look at an access profile within this organization and this breadth. It'll create these communities and these clusters dynamically on the spot. Roughly, I'd say about 1 second is about the performance. When you saw that thing clocking, it was actually doing other checks to make sure, like we're a bank, you don't just get access because you ask for it. You have to go through all these different protocols. So it's also doing all this other business logic behind the scenes. But it's super thin, very low cost, but also very intelligent. And you get the answers you need much quicker than if you're going to thumb through every entitlement and compare one person to the other, like you saw in the first example. So I don't know, we thought it was pretty slick. So how does this help us? So we get two different recommendations coming out of this. And there's a little bit of a feedback loop and continuous learning, which I'll explain here too. So one actually makes the other better. So when you form these clusters, these communities of people with like access, you get, again, I went back, I said, like, we form these clusters with people that have roughly 70% of the same access profile. So based on that, you can get a heavily weighted recommendation. If you're going to work with this group of people, you're probably going to need this list of access or entitlements. And then you can bulk select them and provision them and actually do it before someone onboards to your team, someone comes in the company. So they hit the ground running with 70, 80% accuracy of the data that they need before they even join your team. So they're running day one. And currently, kind of Paul alluded to this earlier, it can take weeks to get the right access in our environment today, and that's actually not uncommon. But if you're hired into a company and you're coming in guns blazing, and then you sit there for 2 weeks, you're like, I can't even work. That's not a great experience, right? On the flip side, that's also a big productivity loss for the company. 2 weeks for every new hire or every time someone switches a role, you can't actually tie it to a dollar amount. You probably could, but it'd be hard to measure it. But you're taking a pretty big productivity hit. So it's a slam both on the associate experience as well as your overall productivity. So the second thing you can do, and this goes back to kind of our risk profile, is you can more dynamically understand what access people might not need. So the same way that you look for the similarity of access profiles and say, well, if you're going to work with this group, you probably need this access, you can also do the inverse. So if you work with this group of people and you have access that nobody else does, the people manager should be asking, well, why do they have that access? Do you really need that? And the reason you do that, particularly as a bank, is like every entitlement you have, every access you have is legitimately a risk point, right? So if that access is compromised, you're increasing risk for the company. So you really only want people having the access they need to do their jobs, and ideally nothing less or nothing more. So it's a balancing act. Now what's neat here is this recommendation of removing access. The more you do this, the more intelligent the other recommendation gets. So let me explain. If you're looking at access profiles and folks have a lot of extraneous access that they don't really need, well, that starts to factor into the similarity index, right, when you're comparing those unions of data sets. So if they got a bunch of garbage in the system, that's actually inflating the amount of access that don't compare them to somebody else. So if you start looking at the recommendation of access removed and working on that, so we have processes today in Capital One that we have to comply with, but it's a little bit more cyclical. This can be much more dynamic and bring it to your attention right away. But if you remove that access, now you've removed the noise from the system, so the recommendations get better. So it's a feedback loop continuously that this algorithm presents you with two recommendations. One helps you be more productive, get people going, and the other one helps reduce your risk. Well, to actually make more accurate predictions or recommendations around what access people need, and it just gets better and better over time. So there's a continuous leading feedback loop, and they're tightly correlated. So the end result, a much improved associate experience and increased productivity. Now I can't show the feedback. So our customers for this are not external. This is all internal at Capital One. Capital One is building technology to benefit ourselves. This is not something that's helping somebody outside the company. But folks that try and, so we're in technology, as Paul said, we've completely revamped our approach. We're hiring like mad to get more and more engineers to do more stuff like this. But the people managers that are hiring like mad, they're spending more time recruiting. They don't want to spend a lot of time doing access stuff. So the feedback we're getting is like, this is making their onboarding of new people, much more seamless. Folks are coming into the company, they're much happier out of the gates. So internally, high satisfaction across all those three personas that Paul was talking about. The part of the organization that has to manage this across the enterprise, identity and access management, it's kind of an industry term. Like, they're very pleased because now their people managers are pleased. It's a big group hug around Capital One. And then again at the end, it's a great lift in productivity that we can measure and see material impacts for engineers joining the company, engineers shifting roles, engineers shifting projects. So the way that we want to be agile, this actually makes us more agile. So last thing I'll add, kind of like Paul talked about earlier, the next time you guys see Jennifer Garner, Samuel Jackson asking you what's in your wallet, remember, Capital One's actually a technology company. And we're using machine learning to solve some pretty cool stuff, not necessarily banking related, but we also happen to do banking. Thanks for your time.